Well, we're going to go ahead and get started today. Thanks for joining us. Welcome to the webcast, Utilizing the Power of Machine Learning to Create a Better Sales Forecast with thinkSCM. I'm Megan Leeds, and I will be your moderator for today. We'll take questions at the end here, but feel free to type them in as they come. You'll receive the slides and the recording by the end of this week, so keep an eye open for that. With that, I'd like to introduce you to our presenter for today. Patrick Green is the founder and CEO of thinkSCM, which is a machine learning software as a service solution for sales forecasting. Pat brings 20 years of supply chain technology expertise to his role as CEO and founder of thinkSCM. He's worked with over 100 global companies for clients in CPG, pharma, life sciences, automotive, and manufacturing, and he started our sister company, SCM Connections, in 2012. And with that, I will turn it over to Pat.
Hi, everyone. Just a little bit of background on myself. My name is Pat Green. I'm the CEO of thinkSCM, and thanks for the introduction, Megan. I appreciate it. Just kind of on my side, I've been doing demand planning and supply chain planning for the better part of 20 years. I've been with lots of companies, et cetera, led some major demand planning and statistical forecasting projects throughout my life. And have worked for major companies, global companies, Fortune 500, et cetera. The one thing that I think that we found is that as we've done a lot of these demand planning activities, we found that most of the companies are in a position where they say, hey, our forecast is not as good as we want it to be. There are significant gaps in our forecast and our ability to execute against it, and it costs us money. So if you kind of think through it, that's almost every company I've worked with, and I don't think there's been one company that would say our forecast is good enough. There's always room for improvement. So that's kind of where, as we've started on our journey, that's where we've come from, trying to get a better forecast and better ways using better technology and newer technology to get a more accurate, more comprehensive forecast. So to kind of set the stage, today from an agenda, we're going to kind of talk a little bit about thinkSCM, just kind of what we do and kind of how we came about. We're going to talk about the impact of poor sales forecast and why it's important to get a sales forecast that's accurate. Then we're going to talk about artificial intelligence, machine learning, predictive analytics, kind of what the difference is between each one of these and why, from a forecasting perspective, it's important to understand. And then we're going to talk about why forecasting and creating a forecast using machine learning, and then talk through a demo, and then finally have a Q&A. So we'll do a system demo on the end with real data, real customer interactions. You can kind of see how the system works and how we're able to create a better forecast based on the causal factors. Okay. All right. So what is thinkSCM? We're a prescriptive analytics platform that utilizes machine learning and AI to provide accurate answers to your complex supply chain problems. Okay, that's great. But what we do is we take, some of the issues that supply chains are commonly presented with, whether that's, sales forecasting or whether that is predictive maintenance, et cetera. And we try and use artificial intelligence and machine learning to really drive a better answer for all of those areas, right? Use the analytic capabilities of ML and AI to provide better answers, more accurate predictions, and help supply chains operate more effectively, okay? So let's talk about the problem today. Poor sales forecasting costs U.S. companies $1.1 trillion a year. So that is a big deal. There's a lot of opportunity to kind of dial in the forecast, but the poor forecasting shows up in a myriad of ways within the supply chain. It shows up in lost sales, expired stock, excess inventory, wrong product, wrong place, wrong time. So those types of things can really drive a company's supply chain significant costs because they don't have a forecast that's very accurate. If you think about it, if you're planning with a forecast accuracy of 50% and you have $1 million in sales for a specific product, you've got a plan for a target between 1.5 and $500,000. That's your target for that particular product. You've got bias, et cetera, on top of it, but that's your target. So that's a wide target. And if you carry too much inventory, you've got risk of obsolescence and excess inventory. If you don't carry enough, you've got a risk of lost sales. So again, that's what costs companies a lot of money over the course of the year. So dialing that in, as opposed if you had 90% accuracy for your forecast, now your window of risk is between 900,000 and $1.1 million, which is much more manageable. And now you've got, expedite costs, all of those things that kind of run into creating additional costs within your supply chain tend to mitigate and slow down over time. Okay, so there have been statistical forecasts, linear, exponential smoothing, linear regression, ARIMA models have been around for a long time. And so a lot of systems have those capabilities, but they never get you quite far enough. And one of the things is, from a technology perspective, one of the answers is using machine learning and artificial intelligence. We now are at a point where this wasn't available 3 to 5 years ago for a variety of reasons. One, the technology from a computing power wasn't available with the introduction of the GPUs and NVIDIA, and being able to crunch through massive amounts of data very quickly. Two, the interconnectivity between data repositories moving back and forth, they just weren't as comprehensive as they are today. And then the internet allows us to have that connectivity to bring all those data sources together, and all of the data that's kind of been sitting on people's machines for the past 20 years, now we can use that in a way that actually makes sense. Okay, so those kind of confluence of factors coming together allow machine learning, why it's available now and maybe why it wasn't available 3 years ago. These algorithms have been around for a long time. It's not like machine learning just came about. The neural networks, et cetera, have been around for a long time, but all of the technology coming together is happening now, and it's only going to become more accelerated over the course of the next 5 to 10 years. Okay, so what are the results of a better forecast? And there's all kinds of statistics around this, et cetera. Why would you want to have a better forecast? Why not just plan to a moving average? Apex, Gartner, the Hackett Group, et cetera, lots have different calculations around this. But in general, a 10% forecast improvement for $1 billion company saves $22 million in increased profitability. So, about 2.2% for every 10% accuracy improvement. Now, that's not linear, obviously, but if you're at 60, 70%, you can get to 80, you should see 22 million drop to the bottom line. So that's a huge improvement and huge opportunity for a lot of these, a lot of companies that are primed to be able to take advantage of the data that they're using today. So McKinsey predicts that machine learning will reduce supply chain forecasting errors by 50%, reduce lost sales by 65% over the course of the next 5 to 10 years, right? So that's a big opportunity for most companies. Okay. So my next slide, I'm going to kind of talk through what the evolution of AI really looks like. And, this is non-data scientist speak. And, if you've got some some propeller heads in the audience, then you'll probably take issue with what I'll say. But I am not a data scientist, although I clearly understand statistics. But as you've gone through the evolution of artificial intelligence, really it's the algorithms and kind of that neural network started in the 50s, and it really was all around understanding how the brain works and processes information, and that's what they call neural networks, and then how you would actually, teaching a machine or programming a machine in an algorithm to actually use that same logical steps to come up with a better answer, make better predictions, et cetera. Well, so this has been around for a long time. It developed and kind of came into, the concept was a robot's going to take over our life, et cetera. But it's developed into, over the 80s, 90s, 2000s, machine learning, which is really kind of that technology coming together and applying very specific use cases for very specific outcomes. So think about things like, the ability to predict in Amazon the next word on your keyword search, right? All of those things come out of machine learning. It's all those algorithms that come together. And then finally, we're moving into, and as that's kind of taken hold, that's moved into deep learning, which is really kind of that next step where you have exponential amount of data, and the machines actually, you know, and I say the machines, the computers are actually, the algorithms are coming together and correlating data in a way that the brain is able to kind of comprehend and would do automatically, but it's looking through multitudes and multitudes of data. So you have a huge amount of data. You've got correlations that the algorithms are bringing together, and then, you know, really driving AI to think like humans, but really being intelligent and reason like humans. And so I just saw an article yesterday about Watson, which is probably the biggest, you know, the name you know best within AI, had a debate class debated a team and performed well within a team, and that your traditional debate, kind of high school debate, but it was able to perform well in that area and actually do reasoning and respond to questions in a reasonable way and build a thesis and an actual argument, which is a huge jump. And that's where deep learning is going to and artificial intelligence is going to. So anyway, that's my little aside. So what is artificial intelligence? It's really the simulation of human intelligence by machines and computer systems, right? So it's learning, reasoning, and self-correction. So it learns from itself, it looks at observations, and then corrects over time and doesn't make the same mistake twice, or tries not to make the same mistake twice. And then it looks at future conclusions. It only understands the data that it knows. So if it doesn't know the data, it doesn't know how to come to a correlation, but it gets better over time. When it makes a mistake, it learns from its mistake and then actually self-corrects. And that's really the key driver in any artificial intelligence kind of application or thought process, is really the ability to self-correct and be better over time. Okay. So how is that different from machine learning? Machine learning is really an application of AI, but it provides systems the ability to kind of automatically learn and improve from experience without being programmed, but it's very specific use case. So think of something that's got a specific application, and it's really a program. So when we talk about machine learning today, we'll talk about machine learning in the application of machine learning for sales forecasting, but it may be another specific correlation or another specific use case or application of the machine learning algorithm. So it's really taking a snippet of that and then using the reasoning and the logic behind AI to solve a specific problem or give a specific prediction, right? But again, it's based on observation. So the aim is to allow the computers to learn automatically without human intervention. And just adjust the actions accordingly so it gets better over time with more information and more data. Okay. So how does it work from a non-data scientist speak? So some of you will laugh out there that are data scientists, right? You need lots of data. You know, the more data, the more opportunity that a machine learning algorithm has to correlate the data to come up with a better predictor. The real key here is that you can introduce the data, and if there's no correlation, that the data, and there's no causation, the data will drive that to be an ineffective input into the algorithm. So it doesn't use it, right? So that's kind of the key piece of this, as opposed to traditional statistics. Traditional statistics would say, I'm going to use this parameter and I'm going to use this feature, this function, but or piece of data, and then apply it to my specific algorithm. I, as a user, need to assume that I have done the research to understand that there's correlation there. Within your machine learning, the system will actually do that automatically. So you'll be able to see the data, and then the machine learning algorithm will take the patterns, causations, et cetera, and test the data and the inputs to find the data and understand the causations that give the results, giving you a better answer, right? So that's pretty interesting, and that's kind of, as we think about sales forecasting, the ability to test and train your model to be able to give you a better forecast based on the data that's associated with it, and testing and training the data to understand, yeah, my model behaves in a specific way, and this is how I get a better answer. Okay. If you look at the trees to the left, that's kind of a random forest algorithm. And what happens is, as you go through each one of the trees or the branches of the tree, you have a specific data combination, and then is tested for that specific combination. And then the testing says, is this an accurate predictor or not? As you move through, right, the accurate predictors become more primary features, and the non-accurate predictors become less feature representative within the algorithm. So again, it's kind of taking all of that on and then building it all, learning from itself, the machine, and then the algorithm, and then actually applying it and coming up with a better answer or a better predictor. Okay, so let's kind of talk about analytics. I'll go through this really quickly, but you know, if you think about an analytics perspective, the first piece of it as we've evolved is your data, which is really, you know, descriptive analytics has been around for a long time, which is in ERP reports, for example, which is really what happened, but I don't understand why it happened or what the correlations were, but I have to do that human input to understand, oh, this piece of data meant that something, I need to take some corrective action. If I had a spike in sales, and I'm going to have another spike in sales because we had a promotion, I can tell you that I had a spike in sales, but the human interaction has to be, I have a spike in sales, it's correlated to the promotion, I'm going to need a human input to make a decision and then take action against it. Diagnostic is kind of that second phase, which is not only what happened, but why it happened. So in this case, I would say, okay, why did I have a spike in sales for a specific week? Why did that happen? And I would do the analysis around it and say, oh, I had a spike in sales because I had a promotion, right? But the human input still needs to say, okay, what am I going to do? When is my next promotion, right? How is that going to have an impact on my data? And how is that going to have an impact on my, my sales forecast? I've got to take some action as a human and then actually make a decision associated with it before anything happens in the system. Predictive is kind of that next evolution of a diagnostic analysis, which is really now I can say I can start applying those conditions around the diagnostic, right? I had a spike in sales, and with my spike in sales that was correlated to a promotion, right? I have a promotion that I'm actually going to model in the system, and that's going to give me an actual output, right? So my decision-making process becomes much more consolidated, and I have a decision to do something at a later date and take action. Prescriptive is kind of that third evolution of analytics, which is really all about automation. So in the terms of sales forecasting, what should I do? What should I build and what should I sell? What can I sell, not necessarily what will I sell? So this is all about an integration of more data inputs and then giving you a recommendation on what you should actually do, and then actually doing it automatically. So in this case, you would say, I have a forecast, I have inventory, I have promotional behaviors, I have pricing behaviors, and this is the amount to maximize my profitability. That's my objective function. And what I want to do is in my algorithm, run promotions, my production schedule, and my pricing conditions based on my objective function, which is to maximize sales, minimize production output, et cetera. So that would happen automatically. And if I had something, I would make an automatic decision. So for example, if I had too much inventory or I had something at risk of going out of stock or expiring, I would automatically take that decision to say, I'm going to run a promotion for that item at this particular retailer because that's going to utilize the stock that I have or the inventory that I have that's at risk. And then now you're actually automating all of these decisions rather than taking human interaction to make a decision and act on it. So it's a huge step, and that's kind of the next evolution of predictive and to prescriptive analytics. Okay. So, all right, so that's a little bit about machine learning, et cetera, and predictive analytics. Now, getting started with ML, so that's great, but how am I going to use it in my supply chain? Really, what you're trying to do is take all the data you've collected in your supply chain over the years, right, and kind of analyze it and say, what can I do to make a better prediction? Combining that with the external factors. So if we talk sales forecasting, everyone knows that I can see my sales history. SAP has it, all legacy ERP systems have it. That's one of the key inputs for sales forecasting. But you have all of these other factors that impact the amount of sales that you're going to generate over the course of the next 3 to 5 months, whether that's weather or economic conditions, promotional activities, pricing, competitors, social media, what's going on with my sales force, et cetera, et cetera. So taking all of the data in your supply chain, combining it with all of these other pieces of data to come up with a better answer, right? And then giving an active business decision around it. So now take all the data, I'm coming up with a better answer, which is my sales forecast, and then I'm applying that and creating a better sales forecast that drives my production, right? What you're using, right, and that's just one example of many that will come out of the next 5 to 10 years in supply chain. We are just at the very, very, very beginning of this revolution or evolution. But what we're trying to do is use these tools, the machine learning and artificial intelligence, to manage and mitigate your supply chain risks, reduce your costs, increase sales and profitability, and decrease the instability and uncertainty in your supply chain, trying to get better predictions so you can be proactive in managing your supply chain rather than reactive. It's kind of always been one of those things that, as a supply chain professional for the past 20 years, it's always about, I want to proactively manage my supply chain. Well, now this is a better tool. These are better tools to do that more effectively. And again, we are just at the very beginning of this. There are 1,000 use cases for machine learning and supply chain that haven't been thought of yet. So think of this as a tool set that's going to drive innovation rather than a tool set that's going to solve a specific problem today. Okay. All right. So we're going to go and then talk about a system. We're going to go into the system demo, and I'm going to show you kind of what we've done for one of our clients. This is live. I would say this isn't live data from their system. It's been masked, and so it's proprietary, et cetera. But what I want to show you is kind of how our tool has taken their sales forecast and really driven accuracy into a level that just wasn't available before. Okay, so we're going to kind of talk about Holt Winters is our legacy. Triple exponential smoothing essentially is the legacy forecast, and we're measuring ourselves against that because that's kind of the best of the multivariate. Maybe ARIMA might be better. We could use that also. But then we're going to measure that against thinkSCM prescriptive demand and kind of look at the results and what it's doing that's better, the inputs that we're giving, et cetera, et cetera. So let's go through that, kind of go through the setup of what we're going to talk about today. It's a food and beverage company, heavy promotion and retail pricing impact. They sell ice cream. So week to week, they may have a promotion. They may reduce the price. They have different influencing factors on their supply chain or on their forecast, right? As a secondary impact, they have marketing, advertising, holidays, and things along those lines. So those are more secondary. And as we've tested the data and tested the model, we'll show you that in a little bit. Those become almost minor or irrelevant. We really talk about promotion and retail pricing drives the model. And you'll see that in our model, those factors which are less relevant get less weighting. Okay. It's about 500 million in revenue for this business unit, and they are assuming about 300K savings per 1 point in improvement in forecast accuracy. So there's real dollars associated with this. Okay. All right. So we're going to go here. Sorry, I'm going to go to my dashboard, and if we have any questions, go ahead and type them in. But what I want to show you is we're going to talk about the specific product today. And what I want to show you is the sales history for this product. If you look, this is our sales history over time. There's about we have about 3 years worth of sales history. Okay. Each one of these spikes represents either a promotion or a pricing activity. Okay. And again, this is all live data. This came from their system. we're not making this up. But every time we have a spike, you will see a huge surge in product, right, in volume. But if you look overall, it's pretty close to, you have a little slight downward trend here, but you kind of have more pretty stable sales within this particular product. Okay. All right. So that's kind of the setup. Well, what does that actually mean? So if you look here, I'm going to look at my sales. Go back to my sales history here. Come back over here, and I'm going to show you. Do another. Go into the pink. And what I want to show you here is what you'll notice is every time I run a retail price reduction and a promotion, I will see a big uptick in volume, right? So here are my sales. Here's my retail price, and I don't have decimals on here, so this would be $2.99. And then here's a promotional activity, and they have a promotional intensity indicator that they use. So one's small, two's larger, and it goes up to 10. So they rate their promotions on a scale of 1 to 10. They also include their retail price, which will be the price at the location. Then here they have a marketing budget. We've kind of normalized this to a 1. We didn't see a huge impact when we were actually showing it, when we were actually testing it. So we've used that as a 1 for today's testing. But the primary driver here ended up being, again, sales, retail price, promotion, right? Our baseline sales for these items was around that 200 to say 250 range. But every time they reduced the price and increased the promotional activity, 2 for 1, buy one, get one free, an end cap, rebates, those types of things, you would see a significant increase in their sales, right? But it's not a 1-to-1. And if they had a promotion, low intensity promotion with a retail increase, or retail price, no price reduction, maybe you had one outcome. If you did both of them together, you had a much bigger outcome, so maybe it was exponential. And it's not a linear relationship between the two. So what they found, what the machine will find out, or their algorithm will make those correlations and actually give you the right numbers associated with it. And again, when you have a pretty drastic price reduction and larger promotions, you see a much bigger volume. So again, my point here being that everything's random. I don't say random, there's a correlation between the promotions and pricing and sales, but it's not a 1-to-1 relationship, it's not a 2-to-1 relationship, et cetera, and it's not linear. And that's really the key of machine learning, is it will test all of those correlations to understand, hey, which one performs better and what does that correlation look like in giving me a prediction for future sales forecast. Okay, so let me get out of this. Okay, so I'm gonna go back to my actual versus forecast here. All right, so what I want to show you here is based on that information, and those are the pieces of data that we're showing, or that we're utilizing. Again, it's not a huge, from a correlation perspective or a feature set, i.e. inputs. At this point, we've got about 4 inputs. And what I'm going to show you here is the results of the 8 weeks prior from a regression testing, and then our actual results going forward. What you'll see is the results of our test in the past. If I do regression testing going back 8 weeks, you'll see that my forecasts are very close to my actual results. And I do this through regression tests to show the accuracy of the model. Okay, I'm gonna come back down here. And I can show that in chart form here. And what you'll see is that my forecast is in orange. My actual sales are in green. And my legacy forecast, the Holt-Winters triple exponential smoothing, is in blue. So when you look at the actual forecast error, my MAPE calculation for this particular product, and again, this is at a customer week product region. So this is at the store level. I'm seeing accuracies at 93% with a bias of 1%. If you take the SAP/legacy forecast, you'll see a legacy bias of 26% and a MAPE of 102% error, right? Because what it did on the legacy side, it doesn't have the ability to correlate these activities or these events to specific data points in time. So this doesn't happen in any timing related perspective every 3 weeks, seasonal, after another event. It happens randomly. So you'll have 3 weeks without a promotion, then you'll get promotion for 2 weeks, or you'll have a pricing condition at one product and one customer in specific weeks, but not at another. So these things are very random, and they're known ahead of time between 8 and 12 weeks. So we're able to predict them going forward. We'll say, if we have that information based on past performance, based on our machine learning algorithm, we can say with some accuracy of what that's going to look like in the future. So if you look up top, our model, so these are kind of the key metrics associated with the execution of our model. We have a forecast accuracy of the model as it ran through the algorithm of 94%. So what does that actually mean? It means when the algorithm ran, it got to a 94% accuracy in the predictions it was making and testing on itself, right? So it takes part of the data and trains, and then the other part of the data and tests. So it's testing the data to prove that its calculations are correct. And based on the model, it shows a 94% accuracy, or I would say accuracy for predictions. Okay, that is not the MAPE, that is not the MAD. Those are not your standard statistical forecasting accuracy measures. Okay, so the other thing we're going to see is based on the result of my model, right? As I ran through the model, you can see my promotions, right, are 53% of the impact of my overall sales forecast. So what does that mean? My promotions drive my sales. And that's what it comes down to. That is the biggest impact on my sales. And that's what really drives it. Retail price being 30%. Okay, so between those two, I know if I'm going to focus on getting my data accuracy correct, I need to go after those two and really focus on those two, because that's really what's driving my sales and my sales volume. We look at the impact of holidays, depletion, which in this case it would be marketing budget. Those don't have nearly the biggest impact, that other ones do, the other factors do. In this case, we have 4 features that we're including within the model. So sales history, promotions, retail price, holidays, and then this is misnamed for depletions. It should be marketing budget. Of those 4, the primary ones were promotions and retail price, and we were at 94% accuracy of the model. That's coming back from the machine learning algorithm that's presenting it back to us. If you look at the overall forecasting of these specific periods, how did I do against my actual model, right, or against my actual sales going back 8 weeks, you'll see that my forecast bias was 1%. So I over forecast by 1%, but my MAPE, which is kind of a traditional method, is 7%. So I'm 93% accurate on this forecast, which is pretty amazing. That's a very, very good forecast accuracy. Again, if I look at my legacy forecast, I'm looking at 26%, and my legacy MAPE, right, my Holt Winters or triple exponential smoothing is 102%. So if you look at that, apply it to $500,000, or apply it to $1 billion company, the savings potential here, and we do this calculation just to show the potential, would be $45 million just by getting almost 100% more accurate within this specific model. Okay, so if I can go from 102% error to 7% error, I could save $45 million. Okay, all right, now I'm going to show you that it's not just one item. We did this for an ice cream vendor, and again, it's the data has been masked. Okay, let's kind of come back here. Here's another electronics manufacturer. They do conference phones. Same type of activities that we feature set that we move into the machine learning algorithm. And we're seeing the promotional activities, very similar results here, right? In this case, the MAPE is 20%, so we're seeing 20% error, but we are seeing a higher bias, right? So we're seeing a higher over forecasting. And typically in a machine learning algorithm, that's because of the trending, takes more data to determine the trend. And in this case, they probably have a item that is trending down. I'll go back to my sales history. You can see the trend here is pretty significant going over time. And what you'll see is that the machine learning takes a little bit longer to pick that up than traditional methods. So when you see a bias like that, what we've done with other clients is we've applied a trend analysis associated with it, and then assumed a trend coefficient to apply after the fact. Okay, so the one thing about this is it's not 100% set it and forget it. You still need to be able to look at the data. You still need to look at your sales history. You need to look at your promotion history. You need to look at your pricing conditions, et cetera. This is not just a, hey, here's my sales history, here's my forecast, and let it run, and we're going to get the best results possible. It's not that easy, and I don't think any data scientist will tell you that. But what we do see is that if you can have the ability to understand, manage your data effectively, manage the model effectively, you're getting much better results over the course of the lifetime, or over the course of the next 12 to 16 weeks of the product from a forecast perspective. So it's huge numbers. We're seeing collectively, in this case, we're beating SAP or the traditional statistical forecasting methods by 61% error down to 20% error. And I would say in general, we're seeing about a 25 to 30% increase in overall accuracy. And I'm going to show you this week. One last thing I'm going to show you, we threw the kitchen sink, and this is everything for them, this particular company, and this is almost everything. Here's your traditional forecast. Again, I think this is several hundred products. Here's the traditional SAP forecast in blue. You'll see our forecast in orange, and then our actuals in green. And in this case, our MAPE is 29%, right? With a forecast bias of 4, so we over forecast by 4%. If you look at under forecast by 4%. If you look at the traditional legacy, you'll see a bias of 56%. So you've under forecast by 56%, and the legacy MAPE at 81%. You'll notice from a data perspective, right, you'll see some of these, a lot of these are based on trend activities where we're following the promotions and the pricing conditions. Those are coming through from machine learning's picking that up accurately, but it's not picking up that trend as you've got a downward trend. And so you see that, you can see that fairly easily when you do an analysis of the data. But if you look at this, I mean, this is a 50% increase in forecast accuracy out of the box, with really 3 factors driving your forecast: sales, promotions, retail price. Between those 3, and that's fairly simple, this is a fairly simple model. Between those 3, we're getting 50% better than your traditional statistical forecast models. And again, the reason for that is that this history, sorry, that's my wrong one here. That's not right. This history is associated, for everything, is associated with promotions, pricing, activities. So the way it actually generates this is highly correlated, and machine learning does a very good job, an excellent job at making those correlations and giving you a much better forecast. Again, what do you need to know? You need to know going forward what those correlative factors are going to be, right? So within this case, they know, and they input into the system they put in whatever their pricing conditions are, and they go out about 12 to 16 weeks. They put in their promotional activities and the intensity going out 12 to 16 weeks. So they have that information with their sales history. We have another client that we're working with that is using their point of sale data going out 12 to 16 weeks, and with a projection in their forecast for 12 to 16 weeks. We have a depletion forecast too. It says what's being depleted at my distributors. I want to bring that into the equation, and we're getting very good results with those particular correlations too. So don't think of this as just promotions and price. Think of you have multiple opportunities and multiple variables that are impacting your forecast that should be part of this equation, that are not necessarily being taken into consideration now. It's not seasonal, it's not trend, and it's not lately. So it's not an alpha, beta, gamma factor. It's something outside of that that is really driving your forecast, these spikes and troughs in your forecast. Okay. All right. So I think do we want to open it up for questions at this point?
Yeah, we've got a few minutes if you guys want to type in questions to that questions box.
We'll go back here. What's that?
Give it another minute or two.
Yeah. We can just open that can. Okay.
Excellent. Well, if there are no questions, this is Pat's contact info, Pat Green at thinkSCM, phone number, web address. Like I said, we'll send you the recording and the slides for this. Reach out if you have any questions, and thanks again for joining us.
Hey, thanks everyone for the time today. Appreciate it. Just reach out for any questions. One of the things that we found, just kind of an FYI, if we've been doing proof of concepts with our several clients and several customers, if there's any interest, it's very, very quick and very simple to put some data through the system and see how it behaves, and look for those correlations. It's not, this is kind of a couple hour activity. So if there's any interest or you want to see what the system looks like, feel free to contact me and just, shoot me an email at this email address or call me. We'd be happy to do it. We're kind of seeing a lot of good results, but it's really kind of driving into the data. So it takes a few times to go through and really understand how to manage, how to get the system to behave in a way that really reflects how your business is behaving, and getting the data set up in a way that reflects how your business behaves and will behave in the future. So if you have any questions, if you want to do that, we're more than happy to kind of do that with folks. That's a pretty fun activity. You'd be surprised at the results you get.
Great. Well, thanks again.